Introducing the 2019-1 Schrödinger release. Let's take a look at some of the new features and enhancements. In continuing our improvements to molecular dynamics visualization in Maestro, we see a new panel for displaying trajectory snapshots. One simply chooses which frames to add as snapshots, whether it's the current frame you're on, as controlled by the trajectory player, a specific set of frame numbers, or stepwise, where you decide the nth frame. For example here, let's define every 100th frame in this trajectory of about 1,000 frames, and then choose Add Snapshots. Now we see a list of snapshots and their corresponding frame number, which we can then easily display, and get a better sense of the overall motion and dynamics of the system. Among the new enhancements to the applications and tasks, the shape screening panel has been updated to include a new GPU shape screening option, enabled provided there is access to a dedicated GPU host. While historically, most compound collections were comprised of already synthesized molecules topping out at around 20 million compounds, Shape GPU can make use of massive synthesizable libraries with well over 100 million compounds. Take, for example, Enamine's real database of 720 million compounds pre-filtered. While efficiently screening such enormous libraries using traditional screening methods on a CPU could take years or require vast numbers of compute resources, GPU shape screening can perform such screens in less than 24 hours, all on a single GPU. Also worth noting is that unlike other GPU-based screening methods, Schrödinger's GPU shape does not require expensive high-memory servers. Strong innovation continues in the FEP Plus panel. Now, when generating a map, multiple custom cores can be defined. Either enter the smarts pattern of each core, separated by spaces, or simply select the cores in the workspace and then notice the smarts pattern for each core is automatically entered, separated by spaces. When defining receptor hot atoms, there's now an option to only use the sidechain atoms rather than the entire residue. This is useful for adding a flexible protein residue in the rest region for enhanced sampling, but where the backbone of the residue is rigid, while the sidechain is mobile. Other useful enhancements include a new option to display pKi units in the correlation plot, the ability to edit experimental pKi values in the Overview tab, and displaying optional experimental errors in the Map tab. While over in the Analysis tab, there are additional columns with new edge convergence classifiers. These include energy convergence for the edge, ligand RMSD with respect to the protein, replica exchange efficiency or density profile. A good profile is one in which all replicas are sampled adequately in all lambda windows, and the classification of cycle closure hysteresis. Overall, these can be used to help highlight possibly unconverged edges worthy of further investigation. Also, expect ongoing refinements to these and new classifiers in future releases. In the AutoQSAR panel, the DeepChem method now will carry out optimization of the internal metaparameters, such as the number of neurons, layers, learning rates, and others listed here. From the user's perspective, you simply need to specify the maximum training time, 20 minutes by default, during which the system will randomly explore different metaparameter combinations to optimize model performance. Among the Jaguar QM panels, now a PCM implicit solvation model is available, including CP-CPM, Cosmo, and SSV-PE. A great advantage of the PCM models is analytic dependence of energy on nuclear coordinates, which leads to smooth geometry optimization convergence over PBF. In the custom R-group enumeration panel, a new option is available to perform partial substitution if multiple positions are defined with the same R-group. With this option enabled, a new column appears with the ability to specify the percentage of positions with the same R-group that are substituted in the enumeration. In the reaction-based enumeration panel, a new set of near drug-like properties is now conveniently available as the default filter criteria, thus ensuring good quality of compounds are returned from the enumeration. While in ligand-based core hopping, there is greater control over the characteristics of the core attachment atoms, including the element, formal charge, and the number of attachments it can make. In Desmond molecular dynamics, the default relaxation protocol will intelligently switch to a membrane relaxation protocol if it detects a prepared membrane system has been loaded. Also, Desmond minimization jobs support running on GPUs. Finally, in KNIME, shape screening has also been updated to support GPU shape, while a new node for automatic compound extraction is available. Here, you provide a PDF containing images of 2D chemical structures and have it automatically recognize and then extract the compounds as smiles. These are just some of the exciting new features in the 2019-1 Schrödinger release. As always, for more information, visit schrödinger.com/new features.